Hi everyone, welcome to Go Classes. So we were discussing SQL complete summary and this is part 3 of SQL complete summary. So let's start. We have already seen what is group by clause in the part 2. In this session we are going to study having clause, but let's do some recap of group by clause. The reason, because see, we will study this having clause, and let me tell you, this having clause is used with group by clause. Okay, so when you have group by clause, then we use the having clause. Okay, so first let's do some recap of this group by clause. This we have already seen in the SQL summary part 2. The link I will provide you in the description so you can check it out. Now we have already seen what is this group by clause. So you can see this is the syntax of group by clause. First we write in the SQL query, first we write select, then attributes. From here we write the table names, where here we write the tuple selection condition, and then we write group by list of columns, list of attributes. So remember, in the group by clause we write list of attributes, a sequence, or I can say a list of columns we write here. Okay, you can see here group by, this is attribute. Okay, so very simple point. Now this is the SQL query template when we use group by. So very simple point. In the group by, the attributes that you are writing, these attributes you must also write as it is in the select clause. Okay, so this is a very simple point, that all the attributes that are there, that are present in the group by clause, those must be present as it is, directly unaggregated, without aggregation. They must be present in the select clause also. Okay, in the select clause we can put aggregation. Okay, we can do aggregation over any attribute. Remember, aggregation we can do on any attribute. Okay, so very simple point. This is the template. This we have already seen in the previous lecture. So you can see group by clause, this is used for grouping. And why do we use group by? Tell me, why do we do the grouping? Because we want to do aggregation on the groups. Okay, yes or no? We want to find the summary, we want to do the aggregation group wise. Okay, so very simple point, group wise aggregation we want to do. That is the reason we use this group by clause. Okay, so group by a sequence of attributes. Okay, also I told you that for every group one tuple will go in the output. Yes or no? When you use the group by clause, then from every group one tuple will go in the output. And remember, the aggregation will happen inside every group. Okay, yes or no? The aggregation will happen group wise. Okay, very simple. All these points we have already seen in the previous lecture, so you can watch it. Now let's see this query and describe the output of this SQL query. Tell me, this is the query. You can see student table is given to you. These are the attributes: first name, last name, GPA, class, grade, school. These are the attributes of student relational table. Now, this query, this SQL query, we have described the output of this SQL query. What is that? Tell me. Very simple. You can easily see we have group by here. Okay, so what we are doing, remember, group by this attribute. Okay, group by, we are grouping by this attribute school. So what will happen? In your table, groups will be created based on school. Okay, this is school number 1. Okay, this is some other school, this is some other school. So remember, tuples will be divided into groups, and the grouping is happening based on school. Is this clear? The this table has many tuples. Yes or no? There are many tuples in this table. These tuples will be divided into groups based on this attribute. The grouping is happening based on this attribute. So remember, you can see like this: for school number 1 this group will be created, for school number 2 this group will be created, and so on. So like this groups will be created. Then what we are doing, then we are selecting school and count star. Okay, means with every school you tell me how many students are there in this school, how many students are there. Very simple point. Okay, so what this query is doing, this query is giving us for every school how many students are there. Okay, number of students in every school, school wise. Yes or no? So remember, the output will be, what is the output? The number of students enrolled in each school. Okay, very simple, the number of students enrolled in each school. This is the output of this query. Okay, so very simple point. Now let's study having clause. What is this having clause? Okay, and this is also very simple. So let me tell you, this having clause is used to filter groups based on group properties. Very simple point. Some groups we can remove based on the group properties, or I can say we will select some groups based on the group properties. Basically, this having clause, this is used to filter groups based on group properties. So remember, after you have created the groups, okay, first you create the groups. After you have created the groups, we can eliminate some of them using the having clause. Okay, so this having clause is used to filter the groups based on group properties. Very simple point. Okay, and remember, having clause will apply on one group at a time. Okay, on one group at a time, this having clause will apply. So, very simple point, that this having clause will apply on one group at a time. Now, let's see this example. Now, here you can see this is your table R. Okay, so you can see from table R, group by attribute A. We will create the groups based on this attribute A, having count star A, having count star greater than 1, and then we are selecting A comma min B. Tell me how many tuples will be there in the output. What will be the output of this query? The question is asking the output of this query. See, this is very simple point. Let me tell you first what will happen in the conceptual evaluation. First, you will do the from clause. Yes or no? So first you will do the from clause. So this is your table R. Now, then what you are going to do? Then you are going to do group by clause. Okay, this is the second clause. Okay, this we will do after the from clause. You can see group by clause. Okay, so group by attribute A. So tell me how many groups will be created? Remember, these tuples will be divided into groups. Okay, these tuples will be divided into groups. The grouping is based on attribute A. So you can see attribute A value here. So this tuple here, attribute A value is 1. Here attribute A value is 1. Here attribute A value is 1. Okay, so these three tuples, remember, I can say that, remember, it's like this, that this tuple, and this tuple. Okay, these tuples are group 1. Let's call it group 1. Okay, very simple. Now you can see in this tuple attribute A value is 2. In this tuple attribute A value is 2. So this will be another group. Okay, so very simple point, this and this, they will create another group. Let's call it group G2. Okay, so remember, this tuple and this tuple, they are in the same group. Okay, let's call it group G2. And finally, you can easily see that this tuple, this will be in another group. Okay, let's call it group G3. So three groups will be created. Very simple. Now we are saying, okay, remember this having clause. When do we apply the having clause? After creating group, based on every group, basically we can remove some group, we can filter some groups. Okay, very simple point. Remember, here you can see having clause will apply on one group at a time. Having clause, this will apply on one group at a time. After you have created the groups, after groups are formed, we can eliminate some groups using the having clause. Okay, so remember, this having clause I will apply. Okay, this having clause I will apply. This is the third step. This having clause I will apply on every group. So if I apply on G1, will G1 pass? Will G1 pass this condition? Who will pass this condition? You can see. Just focus on G1. What is count star of G1? What is count star of G1? That is 3. G1 has 3 tuples. Yes or no? Count star of G1, that is 3. G1 has 3 tuples. So this condition, you can see group G1 will pass. Okay, also who will pass? Group G2 will pass. But group G3 will fail. Yes or no? Is this clear? So remember, the having clause we apply on every group. This is important, that having clause we apply on every group. On every group we apply the having clause. So first you apply on G1, then you apply on G2, then you apply on G3. You can see the count star of G1, that is 3. Count star of G2, that is 2. Count star of G3, that is 1. So you can see, if for this, if I ask you count star, then that is 1. For this, if I ask you count star, that is 2. Okay, for this, if I ask you the count star, that is 3. So very simple. So remember, these two groups will pass. Okay, G1, G2, these two groups will pass. So finally, our output will have 2 tuples. Okay, because remember, only 2 groups are passing. Okay, so number of tuples in the output, that will be number of groups that are passing. Okay, yes or no? number of tuples in the output will be equal to number of groups that are passing. So our final output, what that will be? Our final output, tell me, the final output will be a comma min b. This will be our final output. For every group, one tuple will come. For every group, one tuple will come for every group. Okay, very simple. So you can see from group G1, a value is 1. In this group G1, you can see that a value is 1 and minimum of b, that is a. In the group G2, the a value is 2 and minimum, that is a. Okay, so very simple. So the answer will be, you can see two tuples, 1a, 2a. This is your answer. Is this clear to everyone? So this having clause, this is very simple. The explanation and the working is also very simple. This is used to filter groups based on group properties. Remember, based on group properties. Okay, because having clause will apply on one group at a time. So after groups are created, we can eliminate some of the groups using having clause. Very simple point. Now let's move on. Now let's see this question. Tell me the answer for this one. What will be the output? Again here from table R, this table R is there. So this is the first step. The second step is you create the groups based on AB. We will create the groups based on AB. So you can see A1, B1. So this tuple A1, B1, this tuple A1, B1, this tuple A1, B1. These three tuples are in group G1. Let's call it group G1. Okay, is this clear? So these three tuples, let's call it group G1. Next, you can see A2, B1, this tuple A2, B1, A2, B1. These two tuples, let's call them group G2. Okay, and finally, you can see that this tuple A3, B2, this tuple, you can say that this tuple will go in the group, let's call G3. Okay, so three groups will be created here. Then the third step, having this condition we will apply on every group, right? Yes or no? Okay, on every group we are going to apply this condition. So tell me which group will pass? Which group will pass? Remember, this is the condition we will apply on every group. Check for every group. Independently. Independently. Okay, check for every group. So tell me G1 will pass or not? This condition, G1 will pass or not? We are saying G1. In G1, in G1, the value of B is B1. Yes or no? In G1, the value of B is B1. In G1. In the group G1, the value of B is B1. So B1, yeah, that is correct. Sum of C, and there is and here, and sum of C is greater than 8. Okay, so in G1, let me write it here. See, in G1, what is the value of B? The value of B is B1, that you already know. Okay, and what is sum of C? So you can see 1 plus 2 plus 6, that is 9. Yes or no? So this condition passes. I can say G1 passes. Okay, can I say? I can say that G1 passes. What about G2? What about G2? Tell me. In G2, what is the value of B? In G2, value of B is again B1. Okay, you can see in the group G2, the value of B is again B1. And what is sum of C? So sum of C in G2, that is 8. That is 8. Okay, so G2 does not pass. And what about G3? In G3, in G3, the value of B is B2. In G3, this is not correct. Okay, so again I can say only G1 passes. Yes or no? Correct? Only G1 will pass. Okay, so if G1, only G1 is passing, then this is the last step. Only G1 will pass. So remember, number of tuples in the output, that will be how many groups are passing. Okay, is this clear? How many groups are passing? So this is a note. Okay, when we have group by clause, when we have group by and having clause, then what is the output? Okay, then remember number of tuples in the output. Number of tuples in output will be what that will be? Number of tuples in output will be equal to number of remaining groups. Yes or no? Number of groups that pass. Number of groups that pass. Okay, is this clear? Very simple. So number of groups that pass, that will be number of tuples in the output. Okay, and one note here, if there is where clause, then first we apply the where clause. Yes or no? Where clause is applied before creating groups. This where clause, if we have where clause, then first we apply that. Where clause is applied before creating groups. Before creating groups. Okay, so very simple point. So remember here only one group is passing. So number of tuples in the output will be 1. And what will be the output? Let me know. The output will be A, B, some C, and max D. Tell me what that will be. So you can see A value is A1, B value is B1, some C that is 9, and max D that is 12. This will be the only tuple in the output. This is your output. Okay, is this clear? Very simple point, right? So remember, when you have having clause and group by clause, when you have these clause, then number of tuples in the output will be number of groups that pass. And remember, where clause is applied before creating groups. And if there is no having clause, then tell me, if there is group by clause and no having clause, now no having clause, then all the groups will pass. Then all the groups will pass. The answer will be number of groups. That's it, number of groups. But remember, where clause is applied before you create the groups. Okay, so these results are very helpful. Now let's move on. Now let me tell you the difference between where and having. So did you notice what where does and what having does? Can you tell me? This where is for tuples. Yes or no? See, this is for tuples. This does its work for tuples and this does its work for groups. Okay, so very simple. Remember, where is used to filter tuples. Very simple. Filter tuples. It will filter tuples and it will filter groups. Okay. Second, applies on tuples one by one. Applies on tuples independently, individually. Tuples individually and independently. Okay, the same thing here you can say, but it will happen for groups. It will apply on groups. Okay, again, individually, on every group, it will apply individually and independently. Is this clear? And one more thing, tell me, is it possible that half tuple can be selected? Means if this is the tuple, half tuple you can select. Is it possible that half tuple can be selected? No. Either the whole tuple will be selected or the whole tuple will be rejected. Yes or no? Whole tuple selected or rejected? Whole tuple selected or rejected? Selected or rejected? Similarly here, whole group selected or rejected? Whole group selected or rejected? Either you will select the whole group or you will discard the whole group. So whole group will be selected or rejected. Very simple. Okay, so these are simple points. Having comma where. Okay, so you can see having clause. This is used to filter groups based on group properties. Okay, group properties you can see. This is the syntax. First we write select, then from, then where, then group by, then having. Okay, so this having is used with group by. Is this clear? This having, this is used with group by. Without group by, you cannot use having. Is this clear? Without group by, for example, if I remove group by, can you use having? Can you use having? No, you cannot use having. Okay. So remember, having is used with group by. Without group by, you cannot use having. Okay. Very simple point. And this is the conceptual evaluation. First, you will apply the from clause, then where clause, then group by clause, then having clause, then select clause. Okay. So very simple. Now let's move on. Now let's see this. Okay. See this query and tell me the output. Tell me what this query is doing. Read this query and tell me what is the output of this query. See, from the user table, okay, focus on the user table. We are creating groups based on ages. Means for every age, groups will be created. When your age is 19, a group is created. For age 20, group is created. All the 21 age people are here. 30 age people are here. So based on the age, groups are created. Now, having, now let's see which groups we will select. Count star greater than 100. We will select those groups where number of people are more than 100. Yes or no? Okay. So remember, for example, let's assume this group is gone. Let's assume. Okay. Means number of people, number of users with age 19, these are more than 100. Number of users with age 21, these are more than 100. So let's assume these two groups are gone. Okay. These two groups are remaining. Is this clear? These are remaining. Now, finally, what we are doing, for every age, we are putting the average popularity. So remember what this query is doing. This is giving us average popularity age wise. Yes or no? This is giving us average popularity for every age group. For every age group where at least 100 people, at least 101 people are there, where more than 100 people are there. Very simple. This is giving us average popularity for every age group where more than 100 users are there. So this is the query. Okay, very simple, right? Yes or no? So reading the query is also very simple. Now let's see this query. From user, focus on user. Again, we are grouping by ages. So for every age, a group will be created. Okay, for every age, group will be created. Next, having age greater than 10. Okay, let's assume for every age, for example, for this age, and for this age, for every age, groups are created having age greater than 10. So you can remove this, you can remove this. Okay, these groups will be remaining. And then we are finding for every age, for every age group, what is the average popularity. So answer will be, remember, average popularity for each age group over 10. Yes or no? Is this clear? Please tell me, let me know. So very simple. So reading the SQL query, can you do that? In the gate exam, if they give you some SQL query, can you read it? What this SQL query is doing? Okay. So did you understand group by comma having? These are very simple concept, right? This group by will create the groups, and this having will filter the groups. Okay. And then finally, the select will be applied. Very simple. So I hope you understood all these points, all these examples. I hope you understood. Now let me tell you some rules about having clause. Some rules about the having clause. First of all, you cannot use having without group by. Okay, this is the first thing. Cannot use having, cannot use having without group by. Is this clear? So group by must be there. I can say having clause is used with group by. So you cannot use having without group by. The second point, what can you have in having clause? So let me tell you. See, in the group by clause, in the group by clause, you have attributes. Yes or no? For example, let's assume you have A1, A2, A3. Let's assume these attributes you have. Then remember, in the having clause, what you can write? In the having clause, subset of these attributes you can write. Okay. Subset of these attributes you can write. Now, remember, aggregation you can do on any attribute. Okay. So what you can do? Having clause here, subset of them you can write n aggregated. Okay. subset of them unaggregated. Subset of them can be used, can be used unaggregated. Okay, unaggregated. But remember, aggregation you can do on anyone. For example, the aggregation, if you want to do aggregation, that you can do on any attribute. You can do on A4, you can do aggregation on A1, aggregation you can do on anyone. Is this clear? Okay, aggregation on anyone. Is this clear? Please tell me. So, what is the error then? What is not allowed? Let me know. So, what is not allowed? Please tell me. What is not allowed? This is not allowed. For example, in the group by, let's assume in the group by you have ABC. These are the attributes in the group by. And let's assume in the having you have some attribute D. Okay, in the having, let's assume you have A comma D. So remember, this thing is not allowed. Okay, this thing. Remember, you can have aggregation, no problem. For example, you can have sum of D, that is fine. You can have, for example, count star, that is fine. Okay, you can have, for example, AVG of A, that is fine. These things are fine, but this is issue. This is not allowed. Okay, is this clear? Because here you don't have D. So very simple point. I hope this point is clear to everyone. So remember, group by clause. In the group by clause, sorry, this aggregation happens in the having clause. Okay, so let me write group by, let me write group by here. Group by A1, A2, A3. Okay, and having clause. In the having clause, in the having clause, what you can do? Okay, remember, in the group by we will have list of attributes. Okay, in the having clause we can have subset of these. Okay, for example, you can have A1, A3. Okay, is this clear? You can have A1, A3 subset of, so I can say subset of group by. Subset of group by can be used. Can be used. Is this clear? Please tell me. So very simple point. Remember, very simple point, that in the group by we will put all the sequence of attributes we will put. In the group by we will put list of attributes. Okay, and here you can see in the having clause the subset of attributes you can put and the aggregation you can put. Okay, is this clear? So here you can see group by ABC. Okay, this is not allowed because you can see in the having we cannot put D because this D is not here. Okay, so this is not allowed. I hope this point is clear. Okay, so these are the rules for having clause we have already seen. You can check it out. All the rules we have seen. So remember, this is the rule in SQL 92. I told you for the GATE exam, you have to follow SQL 92. So this is the rule in SQL 92 that you cannot have having clause without group by clause. Okay, so this is the rule in SQL 92. Okay, without group by clause, you cannot use having clause. Okay, you can see this meme. When you use having clause without group by clause in SQL, then SQL 92 does not allow. Okay, very simple. Now let's move on. So is this clear? Let me know. What is having clause? What is allowed in the having clause? What is not allowed in the having clause? Is that clear? So in the having clause, unaggregated attributes must come from the group by clause. Okay. In the having clause, the unaggregated attributes, they must come from the group by clause. Okay. Subset of them you can use here. And aggregation you can do on any attribute. Okay. Very simple. So let's move on. Now, describe the output of the following query. Tell me, what is the output of this query? This student table is given to you. These are the attributes. Select from group by having. Okay. So remember, based on this attribute, you are creating the groups. Okay. You are creating the groups based on school. Like for the school S1, group will be created. For school S2 group will be created, for school S3 group will be created, and so on. Okay, so school wise you are creating the groups, then you are filtering the groups. Okay, then you will filter the groups having okay, average GPA greater than 3. So basically you will remove those groups, those schools you will remove where average GPA is less than or equal to 3. Let's assume this is removed, let's assume this is removed. Okay, so it means that these schools S1 S4 these schools have average GPA greater than 3. Then we are publishing, okay, we are projecting their count star, how many students are there in these schools. So remember the answer will be, what will be the answer? Answer will be number of students in each school where average GPA is more than 3. Number of students in each school where average GPA is more than 3. So number of students enrolled in each school where average GPA is more than 3. Is this clear? Please tell me. So are you comfortable how to describe a query? In the GATE exam, they will give you a query and they will ask you what is the output of this query. Okay, so like this you can easily do. Let's move on. So we have seen this having clause, we have already seen. Now let's move on. Let's see this query. Let's write query for this. Find the age of youngest seller for each rating level. First of all, you tell me how many tables you need. I want age of youngest seller for each rating level. So how many tables I need? I only need this table. Yes or no? The sellers table. Only this sellers table is remaining, is needed. I need only sellers table. I don't need these two. Okay, yes or no? Now you tell me one more thing. In this query, how do you know grouping is needed or not? Who is telling you grouping is needed or not? And based on which attribute we want to create the groups? Yes, I told you that this phrase is telling you that grouping needs to be done. Yes or no? This is the phrase for grouping needs to be done. For grouping. Yes or no? Is this clear? I told you. For each. So for each rating level means I will group by rating level. Okay, I will group by rating level. Very simple. All these simple points I'm telling you that I will do grouping by rating level. Okay, so group by. So very simple point. This is the point that from I only need this table sellers. Sellers table I need. Okay. Do I need to filter the tuples? Do I need to filter the tuples? Do I need where clause? I don't need where clause. I can directly say group by rating. Yes or no? This is rating. Here you can see rating. So group by rating. Then select okay, the age of youngest seller in every group. Remember, for every group the age of youngest seller. Okay, so very simple. Rating comma what is the minimum of age. Okay, minimum of age. Very simple. So this is your answer. I hope this point is clear. Okay, so this is the final answer. Now let's move on. Now let's study order by clause. This is the last clause that we need to study in the SQL query. Order by, the name itself is telling you we are doing some ordering, means we are sorting the result. Okay, the name itself is telling you order by. So we will sort the result either ascending order or descending order. Okay, you can see if we want final output, remember final output, if we want final output to be displayed in sorted order, then we can use order by clause. If you want the final output to be displayed on the screen, okay, in the sorted order, then you can use order by clause. By default the ordering will be ascending order. If you want descending order, then you can use this keyword DESC. Okay, but by default the ordering will be on the ascending order. If you use this keyword, then ordering will be in the descending order. Okay, very simple point. Okay, so you can see this is the syntax. This is the syntax. First we write select, then from, then where, then group by, then having, then at the end we write order by. So remember, this order by we write at the end. Okay. And in the order by we write attribute list. So let me tell you the syntax of order by. The order by syntax is like this: order by, okay, we write attribute list. Okay, for example, you can write a comma b. In front of b you can write desc. Okay, I told you that by default ordering is ascending order, but if you want descending order you can write desc. Okay, so I can say a comma b, b desc means, so tell me, the ordering will happen based on a comma b, a in the ascending order, b in the descending order, right? Yes or no? So okay, remember, the ordering will happen based on this combination. Okay, based on this combination, first priority will be given to a. Then if two tuples have same a value, then priority will be given to b. Okay, don't think, see, some students they think that the ordering will happen based on a and this. No, 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 not separately, not separately, combined. The sorting will happen combined. Okay, if two tuples, this a has more priority, and if two tuples have same a value, then we will give priority to b. Ascending order of a, descending order of b. Okay, so this is the syntax of order by. Also, let me tell you one more thing, that these attributes which you have in the order by, you must put in the select clause. Okay, in the select clause, these attributes must come as it is. Is this clear? Okay, so remember, these attributes, this attribute, they must come in the select clause unaggregated. Okay, and one more thing, what the conceptual evaluation? The conceptual evaluation is this. Let me tell you the conceptual evaluation. The conceptual evaluation is, okay, first what will happen? First from will happen. This is the conceptual evaluation. First from will happen, then where will happen, then group by will happen, then having will happen. Okay, is this clear? Then select will happen. Okay, then distinct will happen if there is select distinct. If there is select distinct, okay, if there is select distinct, then distinct will happen. And at the end, order by will happen. I told you, order by. Read this. If you want the final output to be displayed in the sorted order, then you can use order by clause. Okay, is this clear? So this is the order of evaluation. This is the conceptual evaluation. First, from clause will happen, then where clause, then you will create the groups, then you will filter the groups, then you will project, and then distinct, you will remove the duplicates, and then order by. So this is the conceptual evaluation. Is this clear? Please tell me, let me know. Is this understood? Okay, so very simple point. And one more thing, I told you that order by these attributes. This attribute list must be there in this attribute list. Okay, is this clear? This attribute list must be present in this attribute list. Okay, I told you this a comma b, they must be present here. So you can see this a comma b, they must be present in the SQL clause like this. Okay, I hope you understood about the order by clause. Now let's see some examples to understand. Okay, to understand. Let's see this table R. Okay, now tell me, if I do ordering based on A, then what will happen? See, let me call this tuple. Let me call this tuple R1, tuple R1. Let me call it tuple R2, tuple R3, tuple R4. Okay, so let me call these tuples. I'm just giving some names for my convenience. R4, R5, R6. Is this clear? Now, you tell me back to back some questions I'm asking. If I ask you order by A, then what will happen? If I ask you order by A, by default, ascending order will happen. Yes or no? By default ascending order will happen. Remember, this is same as order necessary. Okay, now you tell me. So let me tell you one more thing, that order by A, this is same as order by A, ASC. This keyword is redundant. This is unnecessary because by default ordering will happen in the ascending order. Yes or no? See, when you write order by A, then the ordering, by default, the ordering will happen on the ascending order. Okay, so this keyword is unnecessary. Order by A, ASC. Yes, this is legal. Okay, this is a keyword given by SQL. SQL gives you this keyword, but this is unnecessary. Okay, if you want to write, you can write, but this is unnecessary because by default, the ordering will happen in the ascending order. So tell me, if I do order by A, then what will be the order of these tuples? Tell me what will be the answer. If I do order by A, then what will be the order of tuples? Very simple. You can see in the ascending order. Yes or no? The the tuples will be shown. The tuples will display in the ascending order. So you can see A value is 1. Okay, so the ascending order, I can say R1 because this also has value 1, value 1, value 1. Yes or no? So I can say R1, R6, R4. Remember, these are same. These are same. So it doesn't matter. Okay, is this clear? Is this clear? Let me know. Okay, so remember, your output will be like this. Okay, your output will be the whole tuple will come or only the attribute A will come. Tell me, only the attribute A will come or the whole tuple will come. That depends on the SQL. Yes, or that depends on the select. That depends on the select. Let's assume select star. Let's assume select star is there. Okay, let's assume select star is there. So the whole tuple will come. Remember, whole tuple is going to come. Okay, so it is possible. Is it possible that first tuple can be 1C, the second tuple can be 1A, the third tuple can be 1B? Is it possible? Is it possible the first tuple can be 1C, then 1A, then 1B? Is it possible? Yes, that is possible. Yes, of course, that is possible because ordering is happening based on A. Here, A value is same. So this is definitely possible. Remember, remember the table is unordered or not? The table is unordered or not? This is unordered collection of tuples. Yes or no? This is unordered collection of tuples that you already know. The order of tuples doesn't matter. Order of tuples does not matter. Can I say this is the first tuple? Can I call it first tuple? No, this is not first tuple. This is a set of tuples. The order of tuples does not matter. Don't say this is last tuple. Don't say this is first tuple. The ordering does not matter. Now, when you use the order by A, then based on A, the results will display. Okay, the result will display based on this ordering of A. Okay, so this is possible. Remember, this is fine, perfectly fine. I can say this is fine. Okay, this is possible. For example, the next tuple can be 2B, the next tuple can be 2A, and the next tuple will be 3A. Okay, so this is perfectly fine. I hope this point is clear. This is also fine. For example, next tuple can be 2A, 2B. That is also fine. I hope this point is clear. Okay, so multiple results are possible. Do you agree with me? Do you agree with me? Multiple results possible. Okay, multiple results are possible. Now, let's move on now. If I tell you to order by B, now what will happen? I tell you to order by B and let's assume select star is there. Okay, select star is there. Now you tell me order by B. Can I use the ascending ASC? That is that is redundant. That is unnecessary. I can use. Okay, if you want, you can use. Remember, this line, this statement is same as order by B, A as C. These are same. Okay, these two things are same. Now, anyway, so by default, ascending order. So what will be the answer? Let me know. So the answer will be, you can see now based on B. Okay, so you can see here value is A. Okay, so this is possible, right? 3A, 1A, 2A. Yes or no? Okay, 3A, 1A, 2A, that is possible. Next, 2B, 1B, 2B, 1B. Next, 1C. Okay, is this clear? Again, multiple results possible. But there is a guarantee. What is the guarantee? Can it come here? There is a guarantee this will be last. There is a guarantee this will be last. Okay, very simple point. Now you tell me one more thing. If I ask you, for example, order by A, comma B, D, E, S, C. Now tell me the answer. Order by A, comma B, D, E, S, C. Okay. So now what will be the answer? Remember, A ascending, B descending. First priority A. Order by A, B descending. So here first priority A. When A values are same, then look at B. First priority A. Okay, is this clear? So remember, first priority A means this tuple, this tuple, this tuple. They are the first priority. Now, among these tuples, who will come first? Tell me. See, these tuples. Okay, first priority A. A ascending. By default, A ascending. Yes or no? A ascending. So first priority A. Now, when A value is same, then B descending. Then B descending. So the answer will be 1C, 1B, 1A. And this is must. Yes or no? This is must. Agree? Next, after that, remember A ascending. So now this will come, A ascending. Okay. But when A value is same, then B descending. When A value is same, then B descending. So 2B, 2A. This is also must. And finally, I can say 3A. So remember, this is a no no other sequence possible. No other order possible. Is this clear? No other order possible. I hope this point is clear. Let me know. Understood? Is this point clear to everyone? So this will be the answer. I hope it is clear. Okay. So tell me one more thing. If I ask you order by B descending A, A ascending. Okay. Order by B descending A ascending. Now you tell me. Now what will be the answer? First priority B. B in the descending order. First priority will be B. So remember, this will be the first tuple no one can stop. This will be the first tuple. B descending. This will be the first tuple. Next, either this or this. Okay. When B value is same, then A ascending. When B value is same, then A ascending. Okay. When B value is same, then A ascending. So it will be 1B, 2B. Okay. After that, then you can see, then these tuples will come. When B value is same, then A ascending. Then A ascending. So it will be 1A, 2A, 3A. So no other order is possible, right? Yes or no? I hope all these points are clear. Okay. So that's it. Is this clear? So order by clause is clear, very simple. We have already seen order by list of attributes, and this list of attributes must also be there in the select clause. Okay, you can see. So this order by, this is also there, you can see in the select clause. Is this clear? This order by, this list of attributes, this is present in the select clause, you can easily see. You can use salary DESC, name ASC. Remember ASC, this is redundant. Okay, this is redundant. This ASC by default ascending. So this is redundant. You can remove this. Okay. Here the first priority will be what? Let me know. First priority will be salary. Second priority will be name. When two columns have, when two tuples have same salary, then this is used. Okay, then this will be used. So very simple. Remember, order by clause attributes must appear in the select list. This we have already seen. Okay, so all these things, all these points we have seen, and the conceptual order of evaluation, you can see. First, we will do from clause, then where clause, then group by clause, then having clause, then select clause, then distinct, okay, and then order by. So this is the conceptual order of evaluation. So all these points we have seen. This is a homework question. Will you try this? Let me know. This is a homework question. Number of tuples in the output. This SQL query is given to you. Here we have group by also, we have having clause also we have. Okay. So these tables are given to you. Okay. So this is a homework question. And so please pause the video and put your answer in the comments. Okay. I provided the answer in the next slide. Okay, you can see I'm not showing it, but in the next slide answer is also there. But you pause the video, you try this, and you write your answer in the comment. Okay. Now the next topic is nested queries. This is our last topic in SQL, that is nested queries. So let's see this. What is nested query? The name itself is telling you that is query within query, query inside query. That is your nested query. Okay, for example, look at this query. Here, can you notice? Okay, just look at this query. Here you can notice that this is your main query. Yes or no? I can say this select. Okay, this is your main query, right? Correct. Okay, I can say this is your main query. Now, this is the main query. And inside this main query, there is a sub query. Query within query, query within query. Yes or no? Select from where. This is another query. So you can call it sub query. Is this clear? Please tell me. So very simple. Nested query means query within query, query inside query. Okay. You can see this is the main query. Inside this main query, you can see there is a sub query. Okay. Very simple concept. Now, where can we put the sub query? Where can we insert the sub query? See, look at this and tell me where this sub query is inserted. This sub query, where is this inserted? This is inserted in the where clause. In the where clause we are inserting this. Okay, so where can we insert the subquery? And the answer, what is that? The answer is you can insert it in the select clause. Okay, so let me tell you, you can insert in the select clause, you can insert in the from clause, you can insert in the where clause. Okay, you cannot insert in the group by because group by will have list of attributes. Okay, having clause. So let me tell you that this subquery you can put here. This subquery either you can put in the select clause, or you can put in the where, in the from clause, or you can put in the where clause, or you can put in the having clause. Okay, in the group by, a list of attributes is used, so here you cannot put. Okay, is this clear? Now this is most, in the where clause, this is most common. Subquery in the where clause, this is most common. This is most common. And in the gate exam, all the questions are based on this. In the gate exam, in any exam, all the questions they are from this. Okay, so this is the most common. We are putting the subquery in the where clause. This is most common. So you can easily see that the subquery we can put in the select clause, from clause, where clause, having clause. Here you can put the put the subquery, but being part of where clause is the most common. Okay, so this is what we need to study. In the where clause, we will use the subquery. This is what we need to study. So let's move on. Now there are two type of subqueries. One is simple subquery, another is correlated subquery. Simple subquery, this is completely independent subquery. This is independent of the outer query. Okay, simple subquery means this is independent of the outer query. Means this simple subquery means this is without correlation with the surrounding query, no dependence from the outer query. Okay, this is simple. Next is correlated. So you can see this is dependent on the outer query. There is correlation with the surrounding query. So there are two type of subquery. Now we will see how to handle them, how to evaluate them. If you have simple subquery, then how to solve the question. If you have correlated subquery, then how to evaluate the query. So let's see this. So first, let's see this example and tell me, look at this subquery and tell me, is this simple or correlated? Look at this and tell me, is this simple or correlated? Is this simple or correlated? This is subquery. I told you this is main query. This is the main query. Okay. Now here you can easily see this is the subquery. Okay. And look at this subquery and tell me, does it depend on the outer query? For example, see, look at the subquery. In the subquery, we are using a new table. Yes or no? In the subquery, we are using this table. This table we are using. Okay. We are using this table. Now, this table, does it have movie ID? This table, does it have movie ID? This table, see, in the subquery, look at this. In the subquery, you are using this table. And in this table, do we have movie ID? Yes, there is movie ID. Yes, there is movie ID. Yes or no? We have movie ID here. Okay. Next, hash dot star ID. So did you notice that in this subquery, we are not using anything from the outer query? In this subquery, we are not using anything from the outer query. We are not using any attribute of the outer query. Okay. So I can say this is a simple subquery. This is simple subquery. Now, one question I want to ask. What is that? See, look at this movie ID. Look at this movie ID. This movie ID is in this table also movie star. See, in the movie star, you don't have movie ID, right? In the movie star, you don't have movie ID. So there is no problem. Okay, so there is no problem. So let me change the question little bit. Let me change the question. Let's assume that here, okay, forget about this. Forget about this. And let's assume in the from you have movie, from movie. Okay, is this clear? From movie means I'm using this table here. Okay, now you tell me this movie ID, you can see this movie ID is in the movie also. Okay, this movie ID is here also, this movie ID is here also. So tell me this particular movie ID, is this of this or is this of this? Let me know. Are you getting my point? See, very simple question I'm asking. You have this movie ID. This movie ID, is it of this one or is it of this one? Let me know. So the answer is not of this. The answer, yes, this is correct. See, this same thing happens in the C language also. Okay, for example, in the C language also the same thing happens, right? In the main, okay, if you have, let's assume in a function, let's assume you have A. Okay, maybe int A. Okay, then you are using A. Scoping rule, yes, scoping rule. So you can see here this A is of the function F. Yes or no? I can say this A is of the function F. But let's assume in F you don't have A. In F you don't have A defined. Now you are using A, but A is defined here. Now I can say this A is of main. Yes or no? So this is the scoping rule. I hope this point is clear. So remember, this movie id, you might be thinking, sir, this movie id, is it of this table or is it of this table? So the answer will be, this is of the closest table. Okay, so remember, this is your scoping rule. Scoping rule. So any attribute basically that belongs to the closest table. Okay, yes or no? So any attribute, whenever there is confusion, any attribute belongs to closest surrounding query. Closest surrounding query. Okay, whenever there is confusion. Is this clear? So this is very straightforward thing. Now, if you don't want any confusion, then what you can do here? If you don't want any confusion at all, then what you can do here? You can just write s dot movie id. Yes or no? Because this is s, so you can write s dot movie id. Okay, s dot movie id you can write. But remember, if you don't write s dot movie id, then this movie id is of this table. Okay, so this is the scoping rule. I hope this point is clear. Now let's move on. Now tell me about this subquery. Look at this subquery and tell me, is this simple or is this correlated? See, this is the main query. Here you can easily see, select from where. This is your main query. Okay. Now inside you have a query. Inside you have this query. Look at this query and tell me, this is your subquery, right? This subquery, does it depend on the outer query? This subquery, does it depend on the outer query? The answer is yes. The answer is yes. You can see c1 dot state. We are using, you can see this arrow. Look at this black arrow. This black arrow. Okay, so you can see. So we are using this c1 dot state. Okay, so this is the attribute of outer query. Attribute of outer query. So this is correlated. Is this clear? So this subquery, this is correlated. I hope this point is clear. What is simple subquery? What is correlated subquery? Is this clear? What is simple? What is correlated? Is this point clear? Now let's move on. Now let's see evaluation of subquery in the where clause. Evaluation of subquery in the where clause. In the where clause, if you have subquery, then how to evaluate? This is what we need to study. Now, first, if you have simple subquery, if your subquery in the where clause that is simple, okay, means without correlation, then it is very simple. First, you execute this simple subquery. Okay, this simple subquery, you execute it once and for all. You don't have to execute again and again. Okay, just execute this simple subquery once and for all and keep using the result again and again. Okay, the outer query will keep using the result again and again. Now let's see, if you have correlated subquery, then what to do? You have correlated subquery. Then this is what you need to do. For every row of outer table, it will be recomputed. Okay, if you have correlated subquery, then it is very simple that for every row of outer table, it will be recomputed. Means take rows of outer query one by one and evaluate the correlated subquery every time. For every row of outer table, you recalculate the inner query. Is this clear? So this is what you need to do in the correlated subquery. So this is how you can evaluate the subquery in the where clause. We will do a lot of examples, don't worry. Okay. See, nested queries, if you want to understand this concept, if you want to understand, then the best way is with the help of a lot of examples that we will do. Okay. But first, let's see some SQL keywords. Some more SQL keywords we need to study. So let's understand some more SQL keywords. Okay. So let's start. Actually, these keywords we need to study. These are set comparator keywords. Okay. Set comparison keywords. Okay. So like this keyword, in, all, exist, any, not in, not all, not exist, not any. So these keywords we need to study. So let's study the first keyword, that is in comma not in. What are these in comma not in keyword? In, this is your membership, very simple. This is your membership. Okay, this is your membership keyword. So is this clear? This is your membership keyword. Remember, this in, this is your membership keyword belongs to. And what is not in? What is not in? This is your non-membership keyword. Okay, does not belong to. So this is very simple. Belongs to, does not belongs to. Okay, it is clear. So let me tell you, the syntax is like this. See, the syntax is like this. Let's assume S is a tuple. S is a tuple. And let's assume R is a subquery. Remember, R must be a subquery. R must be a subquery. So S is a tuple, R is a subquery. Now, if you write S in R, okay, then remember this will be true. When this will be true, S in R. This will be true if R has tuple S, yes or no? So remember, this will be true if and only if tuple S is in R. Okay, is this clear? Next, S not in R. When this will be true, this will be true if and only if tuple S is not in R. Tuple S is not in R. Okay, is this clear? Now, one more thing, that this tuple and this subquery must be compatible. Okay, this is a point. See, S, this is a tuple that I told you. This is a tuple. Okay, and R, this is a subquery. R, this is a subquery. Okay, remember, if you write S in R, or if you write S not in R, now here in these two cases, S comma R must be compatible. Must be compatible. What compatible means? Compatible means, for example, let's assume your tuple S. Let's assume your tuple S that is like this. In your tuple S, let's assume you have, for example, value 10, then some A, and then value 20. Okay, this is your tuple S. Then this R, this is a subquery. Then R must have how many columns? If this is your tuple, then R must have how many columns? Then R must have 3 columns. Okay, is this clear? They must be compatible. S comma R, they must be compatible. Compatible. Okay. So if your tuple is like this, then R must have 3 columns. Okay, and the first column should have integer domain. This should have char and this should have int. So I hope you are getting the point that R is a subquery and S is a tuple, and they must be compatible. Of course, they must be compatible. Okay, so this tuple belongs here, so that we can check this tuple, does it belong here? Is this clear? This tuple, does it belong here? Very simple. For example, let me give you this note. For example, does it make sense? Let me know. If I ask you, I give you this subquery R result. Okay, subquery R result you have. So let's assume this is the subquery R result. Here you have, let's assume 1020 or maybe 10A. Okay, maybe 10B, 20B, like this. Okay, let's assume this is what you have. Now you tell me, can I ask this question that, for example, 10 in this? Now you tell me, can I ask this question? Let me know. Let me know. Is this question valid? This is a invalid. Okay, this is invalid because as I told you, this tuple should belong, not this value, this tuple, right? See, this tuple should be here. They are not compatible. Yes or no? These two things are not compatible. These two things are not compatible. Is this clear? Please tell me. So remember, very simple. This tuple must belong here. This tuple must belong here. Okay, I hope this is clear. So S is a tuple, R is a subquery, S in R means it will be true if tuple S is in R. S not in R, that is true if tuple S is not in R. Okay, these simple points, are they clear? Very simple. Okay, so remember, in comma not in, these keywords, these are set membership keyword. Okay, so basically we want to check if a tuple is in a given set or in a given bag. S in R, we are checking this tuple S is in R or not. S not in R means this tuple is not in this R. Okay, is this clear? And R must be a subquery. R should be a subquery. Okay, very simple. I hope this point is clear. Now, let's assume you have this table. Okay, let me give you a table R. Okay, and some maybe A, B. Okay, maybe 20A, 10A, 20B, and 20C, maybe. Okay, so this type of table you have. Now you tell me, is this correct? For example, if I ask, okay, in the where clause, okay, I'm writing a query like this, that select, okay, select star from R. Select star from R, where A comma B in R. So tell me what will be the output. Tell me what will be the output. Let me know. Tell me what will be the output. If I write like this, see, from R, where A comma B in R, select star. So let me tell you what is the problem here. This is invalid. This thing is invalid. Yes or no? This is invalid because remember, this must be a subquery. You should put subquery here. Okay, this must be a subquery. You cannot use this this relation name directly. This must be a subquery. Must be a subquery. Okay, is this clear? It must be a subquery. You must put a subquery here. So if I want to put R as a subquery, then what to do? I want to put R as a subquery. What to do? I want to put R as a subquery. That is very simple. That is select star from R. Now this is fine. Select star from R. Now this is fine. Yes or no? Is this clear? Now this is a subquery. You can see now this is a subquery. And this is equivalent to R, remember. Yes or no? This is a subquery which is equivalent to R. Correct? Now you tell me what will be the answer. Okay. Now you tell me what will be the answer. I told you this is the first thing. This is the first step from R. From R. The second step, this where this will happen tuple by tuple. Applies tuple by tuple. Okay, yes or no? So for the first tuple, tell me, for the first tuple, will it satisfy this tuple 10A in R? 10A in R. Yes, this will satisfy, this will satisfy, this will satisfy, this will satisfy. So remember, your final output will be same as R. Is this clear? So the final output is going to be same as R. I hope this point is clear. Is this clear to everyone? So again, I am telling you, see, this concept is very simple. Okay, let me just conclude this. Let me give you the conclusion. The concept is very simple, that when you write like this, that S in R, then remember this is a tuple. Okay, this is a tuple. And remember, this is a subquery. Okay, this is a subquery and they must be compatible. Okay, and they must be compatible. This tuple and this subquery, they must be compatible. Simple point. Okay, so very simple point. S in R. So this S is a tuple, R is a subquery, and they are compatible. Okay, so this is the syntax. Very simple syntax. And you already know this in, this is same as your belongs to. Okay, you can see it is your belongs to. And what is not in? Not in is same as does not belong to. Okay, very simple point. Now let's see this question. This data you have student table, results table, and exercise table. So these three tables you have, and this query is given to you. What is the output of this query? What is the output of this query? Is this clear? The question. See this table, these three tables are given to you, and this query is given to us. This query, and the question is asking what is the output of this query. So first you tell me, look at this query and tell me this subquery. Look at this subquery and tell me, is this simple or correlated? Look at this subquery. This is a subquery. You tell me, is this simple or correlated? This subquery. Okay, see, from results. In the results table, do you have CAT and SID? See, in the results table, do you have SID and CAT? These attributes do you have? In the results table, do you have CAT, SID? Yes. Okay, yes or no? One more thing. In the student, do you have SID? In the student, do you have SID? Yes, there is SID. Okay, in the student, you have SID. So tell me, this SID is this of this SID is this of student table or is this of result table? Because remember, in the result table also I have SID. In the student table also I have SID. So this SID, this is of result or student? Very simple. This is of result. This is not of student. This is called scoping rule. Yes or no? This is known as scoping rule. Simple point. Okay. Now let's see. So very simple. This is a simple subquery. I can say this is a simple subquery. So first, because this is a simple subquery, so we will execute this once. Because this is a simple subquery, so executed once. That's it. Executed one time. Execute once. That's it. So let's execute this once. What will be the result of this? If I execute this, what will I get? Remember, from results, where category is H, SID. Those SID where category is H. In the results table, where category is H, where category is H, those SID. So 101, okay. Remember 101 will come, 102 will come, 103 will come. 101, 102, 103. All of them will come, right? Where category is H. So 101, 102, 103, all will come. So remember, the result here will be 101. How many times 101? The result will be 2 times. Yes or no? So actually the result will be like this: 101, 101, 102, 102, 103. This will be the result. Okay, I can say this is going to be the result. This is a bag, right? This is a bag. This is not a set, this is a bag. Duplicates will be there. Okay, so remember 101, 101 two times, 102 two times, and 103. Very simple. That's it. Now you tell me. Okay, so this, now you forget about this. Now you can forget about this. Now this is what we will use. Okay, is this clear? Now you can forget about this one because now this result we are going to use. Okay, so let's see this now. Now we are doing this from the student table. Okay, now focus on the student table where SID is not in this list. SID is not in this list. Okay, remember where clause, tuple by tuple, that you already know. Tuple by tuple. Okay, check tuple by tuple. So SID should not be in this list. So tell me, who will pass? Let me know which tuple will pass. SID should not be in this list. In this list, 101, 102, 103. So which tuple will pass? This tuple will pass. Yes or no? This tuple, this will pass. That's it. Only this tuple will pass. So finally, you are taking first name, last name. Okay, so answer will be Maria Brown. Okay, is this clear? You are finally taking first name, last name. Okay, so your final output, that will be Maria Brown. Okay, so that's it. Is this clear? So you can easily see this is the final output. Okay, now let's move on. Now let's see this. Consider the following query on relation R A comma B. Is this valid query? Is this query valid? Consider the following query. So you can easily see this is invalid. Correct? This is invalid. Okay, because this is invalid because this must be a subquery. This must be a subquery. Okay, very simple. What about this one? Now this is a subquery, right? Now this is a simple subquery. And this is equivalent to R. Okay. Now very simple. From R, where AB is in this, so your output will be same as R. Your final output will be same as R. Very simple. Okay, because this is your table, and for every tuple we are checking, for every tuple of this table we are checking is that in this table. Okay, for every tuple of this table we are checking is that in this table. Okay, so same as R. Very simple. Now let's move on. So we have seen this in operator. Okay, I told you that this in operator, so tuple in subquery. Okay, you have to write subquery. All these points we have already seen. Okay, you can see this. Read this. I want users at the same as some Bart. Okay, some student whose name is Bart. Some student whose name is Bart. I want those users who have the same age as some of these students. So what I will do? What I will do? First, I will find the ages of all the people whose name is Bart. Yes or no? I will find the age of those people whose name is Bart. So this simple subquery I will write. This is a simple subquery. You can easily see from the user where name is Bart. Those ages I want. Okay, those ages I want. Now very simple. Those users whose age is in this set. Those users whose age is same as some Bart. Okay, so those users whose age is in this set, those I want. Okay, so very simple. Like this, you can write the query. So remember, this is a simple subquery, right? Correct. This is a simple subquery. Okay, so very simple. Like this, you can write the simple subquery. Now let's see correlated subquery and how to execute correlated subquery. Correlated nested query. I already told you what to do. In the correlated subquery, the inner query, the subquery uses the attribute of the outer query. I told you. Yes or no? Basically, the inner query, the subquery is dependent on the outer query. There is correlation with the surrounding query. This type of subquery is called correlated subquery. And how to evaluate? That is very simple. Take rows of outer query one by one and evaluate the correlated query each time. Okay. For every tuple of outer table, recompute the inner query. Very simple. Okay, this point is very simple. Let's see this example. Let's start with this example. You can see that table R is given to you, table S is given to you, and this query is given to you. First, you tell me, is this a correlated subquery or simple subquery? Look at this subquery. Look at this subquery. This is subquery because this is your main query, right? This is main query. So look at this subquery. Does it depend on the outer query? Does it depend on the outer query? Yes. Look at this. This R dot B. Yes or no? This is depending on the outer query. You can see this R dot B. Okay. So there is correlation. Now you can see this subquery. This is correlated. This is correlated subquery. So once you know this is correlated subquery, now what you need to do, what you need to do for every tuple of R, for every tuple of R, you will execute this. Okay, yes or no? Very simple point. Remember, for every tuple of outer query, because remember, please understand where. Where means tuple by tuple. Where means tuple by tuple. Yes or no? So remember, from R, from this R, for every tuple you will calculate this. This is what we are going to do. Tuple by tuple. Okay, for every tuple of R, execute this. So this is the point. Tuple by tuple, execute this. Okay. So let me know. Is this clear? So very simple. So let me tell you that for every tuple of R, calculate subquery, inner query. Okay, calculate inner query. Simple. So let's check it. Okay, let me do it. So for every tuple, now let me start with the first tuple. Yes, correct. For every tuple. So let me check this 1 comma 2. Okay, checking for 1 comma 2, tuple 1 comma 2. Checking for tuple 1 comma 2. Okay, let's check for tuple 1 comma 2. So for this tuple 1 comma 2, what is the value of A? What is the value of A? Value of A, that is 1. Okay, yes or no? Value of A will be 1. Simple. Next, inside, what this will be? What this will be? Tell me the output. Tell me the output. So you can see from S, okay, from S, where RB equal to SB. What is RB? What is RB? Remember, I am checking for this tuple. I am checking for tuple 1, 2. I am checking for tuple 1, 2. So what is RB? RB is 2. Yes or no? So where RB equal to SB? Okay, where? So you can see this tuple will pass RB equal to SB. Only this tuple will pass. Yes or no? Only this tuple will pass. So count star, that is 1. So the output will be here. Here the output is count star. Here output will be 1. Yes or no? Is 1 greater than 1? 1 greater than 1. Is 1 greater than 1? No. So this tuple fails. Did you? Okay, do you agree? So this tuple fails. Let me know. Understood? Is this clear? So this tuple has failed. One by one, for every tuple we need to check. This tuple has failed. Now let's see the next tuple. Okay, now we will check for the next tuple. Check for tuple. Check for tuple 3 comma 4. Okay, let's check for this tuple. Now we are checking for 3 comma 4. What is the value of A? That is 3. What is RB? We are checking for this tuple for 3 comma 4. For this tuple we are checking. What is RB? RB is 4. Okay, so you tell me what is the output of this inner query. What is the output? So you can see from S, where RB equal to SB. From S, where SB is 4, where SB is 4. These two tuples will pass. So count star value is 2. So count star value, that is 2. Now you tell me 3 is greater than 2 or not? 3 is greater than 2 or not? Yes, 3 is greater than 2. So this tuple has passed. Okay. So this tuple passes. Simple. This tuple is passing. Finally, the last tuple, you tell me. Now you check for this tuple. Now we are checking for 5, 6. Okay. Because we are checking tuple by tuple for every tuple of R. Now you check for tuple 5, 6. Okay, now you check for tuple 5, 6. Correct. Okay. So what is the value of A? Value of A is 5. Very simple. You tell me about this one. Okay, what is RB? We are checking for this tuple. So RB will be 6. Okay. So from S, where SB is 6. So no tuple will pass. No tuple will pass. Okay. So count star. What is the result? So count star. The result. You tell me the result. You tell me the result. So count star will be give you 0. Can I say the result of this subquery is empty? Can I say the result of this subquery is empty? Can I say the result of this subquery is empty? No. There is one tuple containing 0. Yes or no? Did you notice? There is one tuple containing 0. Okay. So you can see because the result of this, that is one tuple which contains 0. Now you tell me 5 greater than 0 or not? 5 greater than 0 or not? Yes, 5 greater than 0. So this tuple also passes. Okay, that's it. So finally, which two tuples are passing? So you can see this tuple is passing. Okay, for from this tuple. Okay, you can see. So which tuple? These two tuples are passing. So select star. What is the output? Final output. What that will be? Select star. So that will be A, B. These two tuples are passing, right? So answer will be 3, 4, 5, 6. Okay, is this clear? So this is your final output. In the final output, we have two tuples. Please tell me this correlated subquery. This is easy, right? Yes or no? Correlated subquery. This is very easy. Okay, very easy because tuple by tuple. Okay, there is where clause. Where clause means tuple by tuple, tuple by tuple. Okay, where clause that means tuple by tuple. For every tuple, you just recalculate, you just recompute. Very simple. Let's move on. Now let's see another keyword that is exist, not exist. So let's see these two keywords exist, not exist. Okay, let me tell you. First of all, this exist is the keyword in SQL. This exist, this is not the keyword. Okay, this is not a SQL keyword. So who is the SQL keyword then? This is not the keyword. The keyword is exists. This is the keyword. Okay, this is the first thing. Second thing, what is the syntax? The syntax is on the left, you don't have anything. On the left, you don't have anything. The syntax is very simple that exists. Okay, and there is a subquery R. This R must be a subquery. There is nothing on the left. Okay, there is nothing on the left. That's it. So this is the syntax. Exist R, where R is a subquery. Remember, R must be a subquery. Okay. Now, when this will be true, this when this will be true, this is true if and only if the statement is saying exist means something exists in R. This is if and only if R is not empty. That's it. R is not empty. Is this clear? So remember, this will be true. This will be true if R is not empty. Similarly, not exist. Similarly, there is another keyword that is not exist. Not exists. Okay, this is another keyword. Again, this R must be a subquery. Again, this R, this must be a subquery. Okay, so again, you can see this will be true. When this will be true, see the name itself is telling you not exist. Not exist means this R is empty. So remember, this will be true if and only if R is empty. Okay. So this is the simple idea. I hope you understood. Exist R, that will be true if and only if R is not empty. Means something should exist. Something should exist. Not exist means this will be true if R is empty. Okay, is this clear? On LHS there is nothing here. On LHS we have nothing. So this is very simple. Exist R. Okay, let's move on. Let's see this example. Let's solve this. First of all, you tell me again, is this correlated or simple subquery? On your screen, this is the main query that you already know. This is the main query. Okay. Here, this is your subquery. This is your subquery. You tell me, is this subquery correlated or simple? Look at this subquery and tell me, is this correlated or simple? In the table S, do you have B? In the table S, in the table S, in the table S, do you have B? In the table S, do you have B? We don't have B. So whose B is this? So whose B is this? This is the B of R. Yes or no? So is this simple or correlated? Please tell me. Is this simple or correlated? This is correlated. So will you take care? Some students were saying simple. Is this simple or correlated? This is not simple. This is correlated. Will you take care? Because remember, look at the subquery. See, this is your subquery. This is your subquery. In this subquery, there is table S. In this table S, do you have B? There is no B. It means this B is from the table R. Okay, yes or no? So this is correlated. Once you have decided this is correlated, this is correlated. Now, this is in the where clause or not? This is correlated. This is in the where clause. Where clause means this will execute tuple by tuple. Yes or no? This applies tuple by tuple. Of whom? Tuple by tuple of whom? Of R. Yes or no? Tuple by tuple of R. So remember, for every tuple of R, you will check this. For this tuple, you will calculate this. For this tuple also, you will calculate this, and so on. So this is the idea. I hope you understood. So let's start with the first tuple. So tell me, what about this tuple? I am checking. Check tuple 1, 2. I am checking tuple 1, 2 of table R. Okay. So you tell me, what about the inner? What is the result of this inner subquery? This inner query, you tell me the result. There is a star from S. From S, where B less than C. What is the value of B? You tell me. First of all, you tell me what is the value of B. See, we are checking for this. So the value of B will be 2. Value of B, that is 2. So remember, from S, this is your S, from S, where C value greater than 2. Where C value greater than 2. So this tuple, this tuple, this tuple, they will pass. Yes or no? And there is star, select star. All the attributes will be in the output. So the output is what? The output is like this: 4, 12, 6, 14, 8, 16. Okay, there is exist here. Tell me, exist this. Is this empty table or not? Exist. This is a subquery. This subquery is empty table or not? This is empty table or not? This is not empty. Something exists, some tuple exist. So this, I can say this is true. Okay, because this is true, so this tuple passes. Agree? Very simple. Okay, very simple concept, extremely simple concept. Now let's check for the next. For 3, 4. You tell me about this 3, 4 quickly. For 3, 4, what is the value of B? The value of B will be 4. Yes or no? I am checking tuple 3, 4. Tuple 3, 4 I am checking. So value of B will be 4. Okay. And what is the result of this query? What is the result? Remember, from S, from this table S, where C value greater than 4, where C value greater than 4. So these two tuples will pass. Select star. So the output will be CD. Output will be non-empty, right? Okay, so exist will be true. Okay, yes or no? This exist will be true because output will be non-empty. You can see output is non-empty. Output is non-empty table. So this will also pass. This tuple is also passing. Finally, you tell me about this tuple. The B value will be what? When I am checking for this tuple, remember, I am checking check tuple 5, 6. Okay, I am checking for this tuple. So B value is 6. Okay. So what is the result of this one? You can easily see from S, this is table S, where C value greater than 6. In this table, where C value greater than 6. So this tuple will pass. Again, the result is non-empty, right? So this exist will be true because the result is actually non-empty. 8, 16. Okay, result is non-empty. So this exist is true. So this tuple pass. What about the last tuple? Tell me about the last tuple. What about this one? Okay, this final tuple we are checking. Check tuple 7, 8. Okay, check this tuple. Here, the value of B will be what? The value of B will be 8. Okay, the result of this will be what? The result of this. You can see from S, this is table S. From S, where C greater than 8. Where C greater than 8. Okay, select star. So, your empty table you will get. Yes or no? Empty table. No tuple. Empty table. Empty table. So, exist will fail. Exist will be false. Okay, yes or no? Because nothing exists. Because nothing exists. So, exist will be fail. Exist will be false. So, this tuple fails. So, this tuple fails. That's it. So, finally, these tuples are passing. Remember this tuple, this tuple, this tuple. They are passing. These tuple are passing. So, okay, this is star. So, your final output will be, remember, your output that will be like this. That will be AB. Okay, that will be 1, 2, 3, 4, 5, 6. Okay, this will be the final output. I hope this point is clear. This is your answer. So, correlated subquery. Now, can you handle it? Please tell me. Correlated subquery. Can you solve it? Can you handle it? This is very easy, right? Okay. See, very simple. It is very easy to solve. Correlated subquery. With some practice, you can save a lot of time. Okay. Because I am explaining, so I am taking a lot of time. But when you are solving, you can solve this question within 1 minute. Okay, correct or not? So you can see this meme I've created for the correlated query. Basically, what we are doing, did you notice what we are doing? This outer query, it is sending every tuple inside. See, this outer query, it is it is taking this tuple sending inside. Then it is taking this tuple sending inside. Then it is taking this tuple sending inside. Okay, yes or no? So this meme you can check that outer query for every tuple, it is saying ja pooch kya. Okay, then it is sending it to correlated subquery. Anyway, it might be a poor meme, but it might help you. Okay, basically this is the line ja pooch kya. Okay, to every row. Okay, the outer query is telling to every row ja pooch kya. Go and ask. Okay, then it is going inside. So simple. Now, and this is a meme for simple subquery. मैं पहली और आखिरी बार आया हूं. मैं पहली और आखिरी बार आया हूं. Okay, because simple subquery we will execute once and for all. Okay, one time we will execute, that's it. Okay, simple subquery. One time we will execute, that's it. Now let's see. Now let's see this question. Tell me the answer quickly. First of all, you decide this subquery, is this correlated or simple? That is what you need to decide first. Let me know. See, this is your main query that you already know. This is the main query. Now, this query, is this correlated or simple? This is correlated. Why this is correlated? Why this is correlated? Because see, look at this subquery. Look at this subquery. Look at this. From S, in table S, do we have B? Do we have B? We don't have B. So this B is coming from outer query. This B is coming from outer query. Okay. So you can see this is correlated subquery. A student is saying this is the same question. This is not the same question. Now you solve this. This is not the same question. Don't worry. I'm telling you this is not same. Okay. Now you tell me. See, in the last question, there was a star here. In the last question, there was a star here. Now there is count star. Okay. If you see the last question, that was this star. This is the last question. Okay. This time we have count star here. Now you tell me. Now let me know. Okay. Again, the same thing. The same story will repeat from R. Okay. So from R, where? Where means tuple by tuple. Yes or no? Where clause, it will apply tuple by tuple. The same story will repeat for every tuple. Okay. So let's see this tuple. Let's see tuple 1 comma 2. Okay. Let's see this tuple. For this tuple, you tell me what is the value of B. What is the value of B for this tuple? Value of B, that is 2. Okay, so what is the output of this query, this subquery? Okay, that is a count star, right? That is count star. Okay, so you can see that from S, this is table S, from S, where C greater than 2, where C greater than 2, so I can say 3 tuples are passing. So this will be, is this empty? Is this empty? Look at this result. For this subquery, this is the result. Okay, for this subquery, this is the result. Is this result empty? This is not empty. Okay, so because this is not empty, exist, something exist, tuple exist. So this exist becomes true. So this tuple passes. Okay, this tuple passes. Now, now you can easily see. Similarly, this tuple will pass. I'm not going to check it. You can check. This will also pass. I'm telling you, this will also pass. This will also pass. Okay, these will pass. Is this clear? These tuples will also pass. Now let's see the last one. What about the last one? Okay, is this clear? See, this tuple is already passing. These 3 tuples are already passing. Now let's see the last one. Let me check the last one because this where clause, it will apply tuple by tuple from R. So check. So check tuple. Check tuple 7 comma 8. Okay, what will happen for 7 comma 8? The value of B, what is that? The value of B, that is 8. Yes or no? Value of B is 8. So from S, from this table S, where where C value greater than 8, where C value greater than 8. So all the tuples will fail. All the tuples will fail. So can I say empty table you will get? Can I say you will get empty table? For this subquery, can I say you will get empty table? Can you say you will get empty table? No, you will not get empty table. You will not get empty table because count star will be 0. See, the result, you are saying count star and that count star will be 0. Is this empty table? No, there is one row with value 0. This is not empty. There is one tuple with value 0. Don't say it is empty. Do not say it is empty. There is one tuple with value 0. Okay, so tuple exist. This table is not empty. So exist becomes true. this exists, this becomes true, so this tuple will also pass. Okay, please understand, some students what they do, some students what they do, see, here all the tuples are failing, agree? In the table S all the tuples are failing, so some students think, okay, the output is empty table, the output is empty table, but remember empty table means no tuple, empty table that means containing no tuple, containing no tuple at all. Okay, but remember, look at this, look at this table count star, and if I write here for example 0 or null whatever, okay, if I write 0 or if I write null, okay, these things if I write, then it simply means what, this is not empty, this table is not empty, there is one tuple with value 0 or one tuple with value null, so this is not empty. Is this clear? So remember, this exist will become true, so this last tuple will also pass. Is this clear? So remember, because this count star can never give you empty table, do you agree with me? See, do you agree with me, this can never gives empty table. Count star can never give you empty table. Okay, so this exist, this will always be true, this will always be true, so all tuples will pass, so all of them will pass. Okay, so this will be your R as it is, your output is same as R. Is this clear? Please tell me, because count star can never give you empty table. Yes or no? See, whatever you do, whatever a you take, okay, whatever, that doesn't matter, whatever a you take, these things, see, in worst case what can be count star, this will give you one tuple. Okay, whether you take for example, if you take count a, that will also give you one tuple. If you take sum of a, that will also give you one tuple. Whatever you do, they can never give you empty table, they can never give you. I am saying that empty table you can never get. Even for empty table you will not get empty table. Yes or no? Even for empty table you will not get empty table, they will never give you empty table. These things these things they never give out empty table, they never give empty result. Yes or no? Yes or no? For example, if your a itself is empty, let's assume, if your a itself is empty, let's assume if your a itself is empty. Okay, now you tell me, if a is empty, a is empty, now you tell me what will be the value of these. For example, what will be count star? Count star will have one tuple with value 0, one tuple with value 0, one tuple with value 0. What will be count a? One tuple with value 0. What will be sum a? One tuple with value null. What will be min a? One tuple with value null. Is this clear? So they never give empty result. Aggregate functions aggregate functions can never give empty result. Aggregate functions always give one tuple, they don't give more than one tuple. Aggregate functions they always give one tuple, they don't give more than one tuple. Okay, is this clear? They always give one tuple. So very simple, I hope this point is clear. Okay, so don't forget about 0. Some students they just forget about 0, in the, see, this was the result, count star 0. Now some students are thinking this is empty table, some students are thinking this is empty table. No, there is one tuple containing value 0. So don't forget about value 0. Okay, is this clear? Quickly tell me the answer for this question. I'm not going to explain it. Okay, there is not exist here. There is not exist. Means those tuples will pass for which this is empty. There is not exist here. Again, this is correlated query. Okay, again, this is tuple by tuple. Again, this is tuple by tuple. Okay, this not exist. This will be true. Remember, this will satisfy. This tuple will pass. Okay, because this, remember, this will be true when this subquery result will be empty. When subquery result is empty. Is empty. Okay, remember here we are using star, not count star. Yes or no? Here we are using star. We are not using count star or aggregate function. Here we are using star. So only this tuple will pass. Is this clear? So what will be the output? Tell me the output. The output will be only one tuple in the output. That is AB78. Okay, this will be your answer. Is this clear? Tell me the answer for this question. Not exist. Now notice one thing. This count star. So this result can never be empty. Do you agree? This can never be empty because of this count star. So this is never empty result. This is never empty table. Okay, yes or no? Because of this count star. Because of this count star, this is never empty table. If it is never empty table, then this will always fail, always false. Yes or no? Is this clear? This will always be false. This will always fail. So finally, I can say all the tuples will fail. All fail. Okay, so output will be what? Output will be now empty table. Now output will be empty table. Now this is the output. Understood? Let's move on. Tell me the answer for this one. Let me know the answer for this question. This value is greater than equal to 2. This value is greater than equal to 2. This is invalid. Very good. Very good. Don't try. Don't try. See, this is invalid because please notice there is a star here. So this is not a value. This is a table, right? And there is no aggregate here. Please notice this is not a value. This is table. Yes or no? This is a table. And there is no aggregate here. Please notice there is no aggregate. There is no aggregate here. Okay. So you cannot do this. That table is greater than equal to 2. Does it make sense? You have a table which is greater than equal to 2. You have a table which is greater than equal to 2. Does it make sense? Tell me, does it make sense? Table greater than equal to 2. This is invalid. Okay, is this clear? So remember, this is invalid query. Then why were we using so far? So far, this type of query we are using. So far, this type of query we are using. For example, look at this. Is this correct query? Is this query valid? Is this query valid? Yes, this is valid because there is aggregate here, single aggregate. So DBMS knows that you will get a single tuple. Yes or no? There is aggregate, single aggregate, Single aggregate function. Okay, so there is a guarantee that you will get a single tuple. Do you agree with me? There is a guarantee that you will get a single tuple, single column, single column, single tuple, single column, single tuple. Do you agree? Single column, single tuple. Because we are using aggregate. Because we are using aggregate. See, this we have seen in the previous part also. In the SQL summary part 2, I told you when the DBMS, this DBMS, when the DBMS will see that you are using aggregate, okay, the DBMS is standing here. This DBMS will see you are using aggregate. Then DBMS knows that there is a guarantee of single column, single tuple. There is a guarantee. So what this DBMS will do? This DBMS will convert this table into value. Okay, so the DBMS converts this table into value because there is single table, single column, single row. So DBMS will internally convert this table into a value. Okay, because we are using aggregate here. There is aggregate. Okay, I hope this point is clear. Now you tell me the answer for this question quickly. Look at this and tell me, is this correlated or simple? Look at this subquery. This subquery, is this correlated or simple? Again, from S, B, there is no B in S. There is no B in S. So this B is coming from R. So this is correlated. Okay, this is correlated. Now quickly tell me the answer. You can see this is in the where clause. So tuple by tuple. So tuple by tuple. This is in the where clause. Okay, so just solve tuple by tuple from R. Take every tuple and then you check. So tell me which tuples will pass. Directly give me the answer. Okay, look at this. For this will give you what result? Let me know. Okay, for this tuple, the value of B is 2. The value of B is 2. So count star, see count star from S, this is table S, from S where C greater than 2. Where C greater than 2. So these tuples will pass. So remember the result will be like this. The result will be count star. See the result will be count star and here 3. Now, did you notice this is a table? Did you notice this is a table? Table greater than equal to 2. Does it make sense? Table doesn't table. Table greater than equal to 2. Does it make sense? Yes, it makes sense here. It makes sense here because this is an aggregate. Yes or no? Because it is aggregate, so there is a guarantee. DBMS knows that you will get single column, single tuple. So DBMS will convert this into value 2. Internally, DBMS will convert into value 2. So what DBMS will do internally? DBMS. Okay, DBMS will internally convert. Internally converts into value 3. Internally it will convert into value 3. Now 3 greater than equal to 2. Does it make sense? 3 greater than equal to 2. Yes, that is true. That is true. So this tuple will pass. Okay, is this clear? What about the next tuple? So remember this tuple is passing. What about the next? What about this tuple? This will also pass. Okay, these two, they will fail. They will fail. So your final output, what that will be? Your final output will be AB, 2 tuples, 1, 2, 3, 4. This is your final output. Okay, is this clear? Simple, right? Correlated subquery, did you understand? Please tell me. Correlated subqueries. Are you comfortable with all the variations? Let me know. Okay. One more SQL keyword, let me tell you quickly, that is unique and not unique. Okay, it is not much useful, don't worry. In the GATE exam, they will not ask you this keyword, But anyway, let me just tell you for the sake of completeness, let me tell you the definition. The definition is like this: unique, it will check if the subquery has no duplicate tuples. See, let me tell you. Basically, this is the syntax. Syntax is just like exist, unique, and there is a subquery R. Okay, there is a subquery R. Now, this is the syntax. Okay, there is nothing on the left. There is nothing on the left. So unique, comma R. Now, when this will be true, the name itself is telling you unique means actually every tuple must be distinct. Okay, so this will be true if and only if R has no duplicate tuples. R has no duplicate tuples. Okay, is this clear? Simple, right? R has no duplicate tuples. Similarly, there is not unique. Okay, not unique R, where R is a subquery. Now you already know when this will be true. Tell me when this will be true. This will be true if and only if R has some duplicate tuple, some duplication. R has some duplicates. Okay, some duplication must be there. So this is the definition of unique, not unique. The definition is enough. Okay, they will not ask you this in the gate exam. For sake of completeness, I told you. Now some more keywords, that is all, comma, any or some. Okay, there are two keywords that we need to study. One is all. Okay, this is a keyword. Another keyword is any, and some DBMS they will use the keyword some. Okay, these are keywords. Remember, these are keywords, and they are same. Okay, what I suggest, you never use this keyword. Whenever you see this keyword, just change it to some. This is a strong suggestion, else you will make a mistake. Okay, so this is a suggestion that in the question, whenever you see this any, then what you do, you just cut it and you write some. Okay, is this clear? So very simple. So all, comma, some. Now let's see the syntax. Okay, the syntax, let me tell you what is the syntax of all, comma, some. So very simple. Here you can see for all, this is the syntax as some operator. Some operator. For example, let's assume less than, as less than, all are. Okay. See, this is the syntax. Let me tell you the syntax. First of all, this can be any comparison operator. Okay, you can use this, you can use you can use this, you can use this, right? You can use this one, you can use this one, you can use this one, you can use not equal to. Okay, is this clear? So remember, this can be any operator. Okay, this is any operator. Is this clear? Please tell me. So remember, here you can use any of these operator you can use. For example, as less than equal to all are. Okay. Now tell me when this will be true. As less than equal to all are means this must be less than. This must be less than all the value of r. That's it. Very simple. Yes or no? So very simple. S must be less than all values of r. Must be less than all values of r. Is this clear? Please tell me. So S must be less than all values of R. That's it. Very simple. So this is very simple to understand that S is less than all values of R. Okay, understood? Please tell me. So like this. Now you can use this also. You can use any operator, but I hope you understood the meaning. Did you understand the meaning? Please tell me. Let me know. Okay. One more thing. If this R is empty, then all, will it be true or false? See, this all is your universal quantifier. Okay. This is like your universal quantifier. It is like your universal quantifier. We study in first order logic. In the first order logic, this concept we study universal quantifier, universal for all. Okay, this quantifier. So you can see if R is empty, then what happens with the universal quantifier? So if you did not study first order logic, don't worry. If this R is empty, then this will always be true. Okay, if R empty, if you get empty table, if R empty, then this this will always be true, means for everyone it will pass. Are you getting my point? Are you getting my point, that this will always be true? Then this all is always true. Okay, so everyone will pass, so everyone will pass because this all will be always true if R is empty. Very simple, very simple example. Okay, now let's see the next, that is sum or any. Okay, see, in the gate exam they will give you any. What you will do? In the gate exam they are going to give you any, but what you are going to do, you are going to cancel it and you are going to think sum. Okay, just cancel it and write sum. Now you tell me, s is less than some r, means s must be less than some value of r, at least one value of r. Sum means at least one. Yes or no? So s must be less than some value of r, s must be less than at least one value of r. Is this clear? Please tell me. Now you tell me, if this r is empty, if this r is empty, remember sum means at least one, this is your existential quantifier. This concept we study in the first order logic. This is your existential quantifier. Okay, so if r is empty, then what will happen? If this r is empty table, then this will be false. Okay, because sum means at least one. Please notice, sum means at least one, at least one. Okay, now if r is empty, then can you have at least one? If r is empty, then can you have at least one? No. So if r is empty, then this sum is always false. Okay, so no one will satisfy. So okay, so here you can see no one is going to satisfy. Is this clear? Okay, very simple. A nice logo we created. This on your screen here, what you see, this is like the new logo of ISC Bangalore. Okay, you can check it out. The new logo of ISC Bangalore, that is similar to this. Okay. Anyway, let me keep it. So that's it. I hope you understood. Is this clear? All these concepts, are they clear to everyone? Please tell me. Let me know. So let me know these few things. For example, if I ask not, okay, notice not all means not as less than all are. Now you tell me what this will mean. Not all, basically not all. Okay, not all is used like this. Not as less than all are. Not as less than all are. So this will mean what? Okay, so this will be true if if s is, I can say, greater than or equal to some r. Yes or no? Some value in r. Some value in r. Okay, so like this you can handle all these variations. These are very simple variations. That not as, basically we are saying not all. Okay, means s is basically not less than all r, means s is actually greater than or equal to some value of r. Okay, so anyway, so very simple, all these things you can read it here. Very simple. For example, look at this. Look at this. Not as greater than equal to all r, when it will be true? Tell me. Not as, look at this. See here. Not as greater than equal to all r. When this will be true? This will be true when s is less than some value of r. S is less than some value of r. S must be less than some value of r. So can I say s is not maximum? So can I say s is not maximum? S is less than some value of r. So I can say s is not maximum. Okay. Similarly, let me let me also ask you similarly. If I ask you not s, less than equal to some r, or let me use any. If you use any, now the confusion will happen. Now something interesting. Why I'm telling you to write some? See, look at this. If you use any, then the confusion will happen. See, not as less than equal to any r. Then what comes to your mind? What is coming to your mind? Not as less than equal to any r means s is greater than all r. Yes or no? It will come to your mind. It will come to your mind that s is greater than all value of r. Yes or no? But now you think about it. You just change it. You just change it to some. Now you think. Now again think. Now think about it. Not s less than equal to some r. It means s is a, okay, not s less than equal to some r. So here actually s is actually maximum. Here actually not s less than equal to some r. So here actually s will be maximum. Okay. Not s greater than some r. So here s will be minimum. Yes, yes, that is correct. Okay, so here you can see not s less than equal to some r. Okay, so here actually s is basically maximum. Yes or no? I can say s is greater than for greater than all values. Okay, is this clear? Yes or no? It is greater than all values of r. Okay, so very simple. You can read this. Everything that I told you that is written here. Okay, that is given here, so you can read this. But anyway, we have seen all the points. This point, this point, this point. All these paragraph we have seen. Okay. Now some more points. Just few more points I want to tell you. One more point actually. That is, see, look at this and tell me. S in R. So can I write it in terms of all? Write it in terms of all. S in R. In terms of all, write it. How you will write it in terms of all? S in R. All comma sum. Okay. See, for example, S not in R. How you will write this? S not in R. See, this is very simple. S not in R. That means S is not equal to. See, can I write it? S is not equal to all R. Yes or no? Yes or no? See, I am saying S not in R. S is not in R. Now I can say S is not equal to all the values I am saying. For all the values I am saying that S is not equal to them. For all the values I am saying S is not equal to them. Yes or no? Is this clear? So this is very simple. S not in R, that is same as S not equal to all R. So this is what I can say, that this box you can replace with this box. These two boxes are equivalent. Okay, similarly, what about S in R? I can say S is equal to some value of R. S is equal to some value of R. Yes or no? So I can say this box and this box, they are equivalent. Okay. Instead of some, I can use any. Instead of some, I can use any. Okay. So that's it. Is this clear? Please tell me, is this clear? So you can see in is same as equal to any. Not in is same as not equal to all. So these points, are they clear? These are simple points you can easily observe. Okay. We have already seen this is a dangerous combination, exist comma aggregate. Yes or no? These are dangerous combinations, exist comma aggregate in the inner query. Means this type of combination where you have exist and in the inner query you have some aggregate here. It can be any aggregate, remember. It can be any aggregate. Yes or no? It can be any aggregate. Count, it can be count star, it can be sum of a. Basically, if you do this, then what will happen? then remember this will never be empty. This is never empty result. Okay, this is never empty result. So this never true. Sorry, this always true. So this always true. Okay, so this combination, remember, take care. Take care of this combination. Tricky question can be created based on this combination. Okay, so that's it. This is our chapter. We have seen everything. This is our SQL. Okay, let's see one question. Tell me, look at this query and tell me, is this correlated subquery or simple subquery? Look at this subquery and tell me. Look at the subquery and tell me, is this correlated or simple subquery? See, select from where. This is the main query. And here you have correlated, right? Because s1 dot day. So this is a correlated. Do you agree? This internal query, if you look at this, okay, this is a, let me write it here, that this is correlated. Okay. If this is correlated subquery, then how to solve it? How to solve it? Here also score table. Okay, see, very simple. Score table. Finally, you want team comma day. Okay, this is what you want. This is what you want. Okay, these two things you want in the output. Remember, in the output, you want team comma day. Okay, is this clear? Now, score table. Where? So remember, for every tuple, you are going to check. Do you agree? For every tuple, you are going to check. So for the first tuple, let me call it tuple number T1. Let me call it tuple T1. Okay. So you tell me, for tuple T1, what are you going to check? What are you going to check for tuple T1? Okay, because this is correlated subquery. So for every tuple of outer query, okay, for every tuple, for this tuple, let's check for this tuple first. This is our tuple that we want to check first. Okay, so now we want to check for this tuple. So here for this tuple, we will check that these are four runs, right? Yes or no? So this four run, this should be less than equal to what? Okay, runs should be less than equal to, four should be less than equal to all. Okay, less than equal to all. But what all? Here from the score table on the same day. See, here you have Sunday, right? Notice. Here you have Sunday. So day must be same. Where day is same. Sunday means, so this tuple you will check. Okay, this tuple, Sunday. So these okay, these tuples you will check. Yes or no? These tuples. Okay, from the score table where the day is same, where day is Sunday, because we are checking for the first tuple. In the first tuple, day is Sunday. So where the day is Sunday, on that day you find select runs. Okay, you find these runs. These runs you find on Sunday. All the runs you find, basically on Sunday you find all the runs. These are all the runs which are made on Sunday. 27, 24. These are all the runs made on Sunday. Do you agree? All runs made on Sunday. Yes or no? Okay. So now 4 must be less than all these runs. 4 must be less than equal to all these runs. Is this true? Is this true? 4 is less than all these runs. Less than all. 4 is less than all these runs. That is not true. That is not true. Yes or no? So T1 fails. So this T1, this fails. Okay. Is this clear? So this T1 tuple will fail. Do you agree? T1 tuple is going to fail. Now let me tell you one very beautiful thing. That is, now you don't have to analyze every tuple one by one. Now you don't have to analyze every tuple one by one. Now you can understand this query. Basically, what this query is doing, for every tuple you will check that runs must be less than equal to on that day all the runs. Means, are you understanding? Please tell me. See, first you are checking for this tuple. Okay, we started with tuple number 1. We started with this tuple. For this tuple we are checking that runs must be less than equal to all the runs made on that day. Runs must be less than equal to all the runs made on that day. Means we are interested in those tuples where runs are made which are least on that day. Yes or no? Did you notice? Basically, remember, we want those tuples. We want those tuples where runs are least on that day. Yes or no? Yes or no? Is this clear? We want those tuples where runs are least on that day. Okay. So least runs on Sunday, what are those? For Sunday, this tuple will pass, this tuple will pass, these two tuples will pass for Sunday. And because of Monday, which tuple will pass? This tuple will pass because of Monday. Yes or no? So finally, three tuples in the output. Okay, yes or no? Three tuples in output. Three tuples in output. Isn't it interesting, this question? Please tell me, did you understand? Let me know. See what I did. Very simple thing I did. I started with the first tuple. Remember, this is what I did. I took this first tuple. This tuple I took. I did the analysis. And after the analysis, I found that we are interested in those runs which are least on that day, because day must be same. Yes or no? Day must be same. So we want those runs which are least on that day. For example, we want those runs like this run number 2, run 2. This is least on that day. On Sunday, this is least. Yes or no? On Monday, this is least. So finally, I can say that three tuples will be there in the output. Is this clear? So what is the final output? There will be three tuples in the output. Remember, this tuple, this tuple, this tuple. And we want only team comma day. Team comma day. So team comma day, that is carp sun. Yes, this is correct. Okay, this is correct. Next. This is also correct. Next. This is also correct. So the answer will be option D. Is this clear? So this is the answer. Let me know. Is this clear? So the answer will be option D. Please tell me, did you understand this question? From this question, you can observe one thing. What is that? Whenever you have correlated query, then if you check 1 2 rows, then you will find the meaning of the query. Do you agree with me? In the correlated query, once you check one or two tuples, just check one or two tuples you check, then automatically you will find the meaning of the query. Then you don't have to solve the question. From the meaning of the query, you can solve the question. You can save a lot of time. Is this clear? Please tell me. One thing you notice, again, one thing you notice, if you solve this question for every tuple, then how much time it will take? Like you are checking for this tuple, then this tuple, then this tuple, then this tuple. Okay, for every tuple, if you keep doing, then how much time it will take? It will take a lot of time. But after one tuple, just do this tuple, do the analysis of this tuple, then you can find out the meaning of this query, what this query wants to tell you, and then you can solve the question. Please tell me. So this is a beautiful question, right? Okay, this is telling you that you just understand the query after analyzing one or two tuples. Just analyze one tuple, maybe two tuples, no problem. Okay, take two tuples and analyze them, and then understand the meaning of the query, and then you solve the question. So you can see option D is correct. All are correct. Okay, so that's it. So we have seen everything. One small topic I want to tell you, that is joins in SQL. This is a very small topic. Joins, like natural join, outer join, okay, all these joins in the SQL. Actually, this is not a topic because these joins are same as your relational algebra. Nothing, no difference. Okay, remember the join concept. Joins in relational algebra, they are same. They are same in here. Joins in SQL. What is the only difference? What is the only difference? Here duplicates are not eliminated. Yes or no? Here duplicates are not eliminated. Here duplicates are not eliminated. Okay. Very simple. This is the only difference. For example, look at this. This is table R. This is table S. What will be cross product? How many tuples in the cross product? This is table R. This is table S. So in R cross S, you can see for every tuple, you will join with every tuple. Okay. Every tuple you will join with every tuple. So there will be total 6 tuples. You can see. You can see there are total 6 tuples. Yes or no? And you can see there are duplicates. For example, these two are duplicates or not? They are duplicates. All of them are duplicates. Okay, so duplicates are fine. Okay, here 2 tuples, here 3 tuples. So in the answer, you will have total 6 tuples. This is your cross product. And how many attributes will be there in the answer? In the cross product, here 2 attribute, here 2 attribute. So 4 attribute will be there. Here m tuples, here n tuples. So mn tuples will be there. Okay, agree? This is what happens, right? If you have table R, if you have table R, and let's assume here you have X, maybe you can say Y attributes, or maybe I attributes. You have total I attributes and M tuples. Okay, and in the table R, let's assume you have J attributes and N tuples. Now you tell me the answer for cross product in the R cross S. In the R cross S, what will happen? There will be I plus J attributes, and there will be mn tuples. Okay, very simple. Here you can see. Okay, AB, BC. Name can be common, no problem. Name can be common, no problem. You can see that 4 attributes and 6 tuples will be there. Let's move on. For example, this is your natural join. This is your natural join. If someone asks you natural join, what your answer will be? See, just think about it. If I ask you what is the natural join of this, then what you will do? Equality of common attribute. Yes or no? If I ask you natural join, then what you are going to do? If I ask you natural join, this symbol, R natural join S, then what you are going to do? Equality of common attribute, common name. This is the common name attribute. You will do the equality of this attribute. Okay. So this tuple will match with this tuple, and this tuple will match with this tuple. So finally, in the output, there will be 2 tuples and 3 columns. In the natural join, do you write B 2 times? Will you write this B 2 times? Will you write this B 2 times? No. You will write only 1 time, right? Yes or no? So very simple. This is your natural join. This is the result. This is the result of natural join. Okay, let's move on. You can see, if I give you this condition, then what will happen? Or if I give you this condition, conditional join, or I can say theta join, conditional join or theta join. Now the output will be this, because you can see this is the condition. R dot B should be less than S dot B. Okay, RB should be less than SB. So this tuple will match with everyone. See, sorry, this tuple will match with these two. RB must be less than SB. So this tuple will match with these two. Okay, and this tuple will also match with these two. So 4 tuples will be there. This is conditional join. Because this is conditional join, you can see this is conditional join. So 4 attributes will be there because it is conditional join. Okay, so join is also very simple. I told you there is nothing here. Let's solve this question quickly. Table R is given to you AB, table S is given to you BCD. This SQL query is given to you. Select from, look at this from R full outer join S. Okay, from R full outer join S on this condition is given to you. Okay, this condition is given to you, remember. So now tell me what will happen. First, you tell me about the full outer join. Basically, this full outer join. The symbol is what? The symbol is this, right? This is the full outer join. Agree? Yes or no? This is the symbol. Okay. So you can see this is the symbol of full outer join. And the condition is given to you. The condition is that R dot A is R dot A greater than S dot B and and R dot B equal to S dot C. Okay, this is your. So now you tell me how many tuples will be there in the output? How many tuples in the output? Tell me. Simple. Okay. So there will be five attributes. We are projecting all the five attributes. So remember, there will be five attributes, right? There will be RA. There will be RA, I can say. Okay. There will be RB. There will be SB. There will be C. There will be D. So these will be the attributes. How many tuples will be there? What is the number of tuples? We are doing full outer join. Full outer join. So first of all, this condition is already given to you. That is RA greater than SB and RBSC. RB is equal to SC. So this tuple will match with what? Tell me, this tuple will match with whom? Remember, RB equal to SC. RB equal to SC. This will not match with anyone. This tuple will not match with anyone. So can I say this is dangling tuple? This is not matching with anyone. This is dangling tuple. This is not matching with anyone. What do we do with dangling tuples? With dangling tuples, what do we do? In the full outer join. It is full outer join, full outer join. So with the dangling tuple, we will write like this: null, null, null. Okay, is this clear? What about this tuple? This tuple will match with whom? You can see RB equal to SC. So this will match with this. RA greater than SB. Yes. So this will match with this. Okay, these two tuples will match. So they are not dangling tuples, right? They are matching. So they are not dangling tuples. So the answer here 3, 4, 4, 6, 8. 3, 4, 4, 6, 8. Okay, so very simple. 3, 4, 4. Sorry, sorry. 3, 4, 2, 4, 6. 3, 4, 2, 4, 6. Okay, 3, 4, 2, 4, 6. Okay, next. What about this? What about this one? 5, 6. Again, RA greater than SB. Don't forget about RA greater than SB. RA greater than SB. Yes, this will match with this. Okay, so it will be 5, 6, 4, 6, 8. 4, 6, 8. Okay, so that's it. What about this one? This is dangling. Okay, yes or no? This is a dangling. And this is, remember, this is full outer join. This is full outer join. So there will be one more tuple. This is full outer join. So there will be one more tuple, that is null, null 479. 479. Okay, there will be one more tuple. Null, null 479. Is this clear? So how many tuples will be there? Total four tuples in the output. Okay, is this clear? Four tuples in the output. We are projecting all the attributes. So four tuples in output. In the output. So here you can see, okay, the question is asking who is dangling tuple. The question is asking who is dangling tuple. Let me tell you the definition of dangling tuple if you don't know. Dangling tuple, in any join operation, in any join operation, the tuple which does not match with anyone, a tuple that fails to pair with anyone, that is dangling tuple. A tuple that does not match with anyone. So you can see this is dangling tuple 1 2 of R, that is dangling, and 4 7 9 of S, that is dangling. I can say, for example, if I say 4 7 9 of S, that is also dangling. This is also correct. Okay. So that's it. I hope you understood. You can see four tuples in the output. These are the four tuples. Okay. These are the four tuples in the output. So this is dangling tuple. This is dangling tuple. These are the dangling tuples. What is a dangling tuple? The definition you know. I told you. Dangling tuple means a tuple that does not pair with anyone. That is your dangling tuple. Okay. And remember, we are discussing full outer join here. That's it. Tell me the answer for this question. This is UGC NET August 2016 question. You can see this question. Consider a database table R with attributes A and B. Which of the following SQL query is illegal? We have database table R with attributes A, B. These are the attributes. Now, which of the following SQL query is illegal? Select A from R. That is fine. Okay. Yes or no? Select A from R. It is fine. Next. Select A, count star from R. This is illegal. Yes or no? This is illegal because remember I told you if there is no group by, you already know that when there is no group by from R, okay, and there is no group by, when there is no group by and you are using aggregate, see, count star, you are using aggregate. When you are using aggregate, then you cannot use unaggregated attribute. Yes or no? Is this clear? I told you that when there is no group by, here you can see there is no group by. Now you are using aggregate function, then you cannot use unaggregated attribute. Okay, so this is illegal. Okay, this combination I can say this is illegal, or I can say this is invalid. Okay, what about the next one? Is the next one fine? There is group by here. Okay, because there is group by, you can see there is group by here, group by A. So A is there, count star is there. It is perfectly fine. It is perfectly fine. Yes or no? Next, what about this one? AB is there, AB is there, count star is there. This is also fine. Okay, so that's it. So this is illegal. The question is asking what is illegal. So remember, this is invalid. All other are valid. So this is your UGC NET question. Okay. So that's it. We have done all the SQL summary. We have completed the SQL summary. I hope you liked this session. SQL summary part 1, part 2, part 3. The complete SQL we have discussed. Each and every concept, all the type of questions, every tricky question. Okay, anything that you need to know for your gate exam preparation, that we have told you, that I told you in this summary, SQL summary. Now you can solve the gate question. Let me tell you, on the Go Classes YouTube channel, you can find this. On the YouTube, just put Go Classes SQL. See, SQL gate questions. This video you will find, in this video many SQL gate questions I have discussed. Okay, many SQL gate questions I have discussed in this video. So now you can watch this video. Complete analysis for each gate question. I have done the complete analysis. So you can just Google this Go Classes SQL. Okay, this SQL gate question video you can search and you can watch it. Okay, you can see. Okay, you can see this. It is just a 2-hour video. You can watch it because the complete analysis of many SQL gate questions I have done in this video. Okay, so that's it. This is our lecture. All the slides are over. This is your SQL complete summary. So please tell me, did you like this? Did you like SQL complete summary? Part 1, part 2, part 3. Complete SQL I have discussed from scratch. All the concepts, everything. All the type of questions, all the examples, everything we have seen. Okay. So if you did not study SQL main course, Then also you can watch this SQL complete summary, you can watch, and then you can solve all the gate previous year questions. Now you can try all the gate previous year questions, you can try. You can also try Go classes weekly quizzes of DBMS. Solve and try all the weekly quizzes. In the weekly quizzes, many beautiful questions are there, and for the weekly quizzes, video solutions are already provided. Okay, so just try those questions, weekly quizzes, and get previous year questions of DBMS SQL. You can try. Okay, thank you everyone. I hope you loved this session. Please like this session and please put your comment. Okay, please put your feedback in the comment. Let me know, did you like this session or not? So please share your feedback in the comment. Okay, thank you.